for this question, you are being tested on the quadratic function and inequality. Okay, so there are three parts to this question. For part A, it is actually testing you on quadratic inequality, but some students will have a bit of mind block. Okay, so let's say, okay, I'm going to break the question for you. So right now the question is saying that the curve lies above the straight line. So this is a small curve. So the curve is lying above the straight line. So it will be something like this. So we are interested in the portion where the curve lies above the straight line. Okay, so you just really do a direct inequality. So it's just the curve greater than 11. So while you're doing that, you will form the inequality. And from the forming of the inequality, you can do the shading that is above the x-axis. So this will be my number line. Okay, so then you will represent this on the number line to show them. So when you represent it on the number line, you need to show the number -1 and 4 on the number line. But try not to just show these two numbers. Okay, you show the range of numbers that cover this. So usually I will write out the full range. I will write a little bit more than -1 and a little bit more than 4. Then I will show the number line. Okay, so part A is just a direct inequality. Part B involves simultaneous because you are actually given a straight line that is tangent to the curve. So you are given a straight line that is tangent to the curve. I will show you this simultaneous method first. So if I do this simultaneous method, I got to do a discriminant. That means if I try doing a simultaneous equation, okay, then there's one root. I should execute my discriminant. The condition for the discriminant will be one root. And after the simultaneous, you should be able to get your A, B, and C. So your A, B, C should have the unknown that we are interested in. So using this, A, B, C, we put into our condition and we'll solve for K. So that is the discriminant method. However, because all of you, sometimes some of you will be thinking along this way. Okay, I show another method. So this is the curve. Okay, and this is the tangent. So some students, right, will actually deduce that this is the gradient of tangent, which is correct. Some students will deduce that this is the gradient of tangent, which is dy dx. If you are thinking along this way, you are correct also. So it will be dy dx equal to 2. And how are you supposed to make use of your dy dx? Your dy dx will come from your curve, which you will get a 4x minus 6. So you execute your dy dx equal to 2. You will get the coordinate. So in fact, you will get the coordinate P. So you will be able to get the coordinate P. The 2 times 4, 8 minus 4 minus 4 minus 4 plus 3 is -1. So in fact, you find the coordinate first, which answer the question here already. So if you are doing the dy dx method, you will have answered the question the third part of the question. Then, but the question here is asking for K, which is also very easy. This will be the common point between the curve and the straight line. So what you can do is you put in this point into the straight line. You will still get the same answer. So you will still get the same answer, and you will also be finding the coordinate that the question wants. So would it be okay to be doing this? Yes, it's totally okay. It doesn't matter if you don't answer it in the sequence, as long as you use the correct technique, logic. It's not like some fluke logic that you happen to get it. So if you relate to the dy dx equal to 2, yes, go ahead. You can still get the same answer. However, if you didn't, if you're doing the discriminant method, you get the k equal to -5, then where do you go from there? So where do you go from there to get the coordinates of P? So what you can do is you substitute back to do the simultaneous one more time. So you can substitute back to do the simultaneous, which means, right, you can just put in the -5 here. So that's exactly what I did. So I meant to redo the whole simultaneous equation. Okay, but ultimately if I do the same simultaneous, right, I will get back to this same equation. So I will just continue from there and I will get the coordinates. So if you're doing by the discriminant method, you will find K first and put back your K to resume back the simultaneous in order to find P. However, if you're using the dy dx method, you will find the coordinate and K. Okay, with just a flow of method. So either way are correct technique and correct thinking. So you can choose.